Chapter 3, Probability, Section 3132. Statements of probability and odds are referenced often in various media and many fields, including political polls, sports, and social statistics. Have you noticed? But do you know the difference between probability and odds? Many times people use those two words interchangeably, but they do not mean the same. So let's explore. Review of probability. First of all, definition of an event. Collection of outcomes that satisfy a specific condition. For example, when throwing a standard die, the event of throwing an odd number is the collection of outcomes 1, 3, 5, which includes 3 possible ways. The probability of an event is the ratio of favorable outcomes to the total possible outcomes, or we consider that part to whole. For example, the probability of throwing an odd number on a standard dice, our favorable outcomes would be any odd number, as we've already mentioned, the possible outcomes of 1, 3, or 5. There are 3 possible ways. The total possible outcomes on a standard 6-sided dice are all the numbers 1 through 6. So there are 6 possible total outcomes. 3 divided by 6 can be reduced to 1/2. So the probability of getting an odd number would be 1/2. Probability can be expressed as a fraction, like 1/2, or a ratio, 1 to 2, or a decimal, 0.5, or as a percentage, 50%. Note, the probability of an event can range from 0 to 1, where 1 is an impossible outcome, 1 which corresponds to 100% that we know will happen for certain. Continuing on, we're going to discuss the difference between experimental probability and theoretical probability. An experimental probability, just as it sounds, is if we are completing an experiment. The actual number of times that a certain event A occurs divided by the total number of trials or the number of times we complete that experiment. The theoretical probability of a certain event happening is the number of favorable outcomes of event A, of a certain outcome, divided by the total number of outcomes in the sample space where all outcomes are equally likely. So it is our favorable outcomes over our total. So we just discussed a little about probability. We're going to move now into trying to explain the difference between probability and odds. Let's consider choosing a heart from a deck of cards. Keeping in mind that in a deck of cards, there are 13 red hearts, 13 red diamonds, 13 black spades, and 13 black clubs. So in this deck of cards, where there are a total of 52 cards, choosing a heart, there are 13 hearts, 13, out of my total 52 possible outcomes, and we find the probability to be 1/4 or 25%. When discussing odds, we need to be specific. It is not enough to ask, what are the odds? We need to ask, what are the odds in favor versus what are the odds against something happening. Odds in favor is the ratio of the favorable outcomes to the unfavorable outcomes. Favorable to unfavorable. Keeping in mind that our favorable outcomes plus our unfavorable outcomes gives us our total possible outcomes. So let's continue. What are the odds in favor of choosing a heart from a deck of cards? So our favorable outcomes would be the hearts, and there are 13 hearts. Let's consider the number of unfavorable outcomes. This is going to be our total possible outcomes, subtract our favorable. The total outcomes are 52 possible cards in a deck of cards. If we subtract the 13 favorable hearts, we are left with 39 other cards that are not hearts that we call our unfavorable outcomes. So our favorable to our unfavorable outcomes. 13 out of 39, and we always reduce those fractions to lowest terms. We can divide each by 13, and we end up with a fraction of 1/3, or we write that as a ratio 1 to 3, favorable to unfavorable. Odds against is going to be the ratio of unfavorable outcomes to favorable outcomes, as written here. Okay? So considering the same example, what are the odds against choosing a heart from a deck of cards? Our unfavorable, as we've already discussed, there are 39 unfavorable or non-hearts in the pack, to favorable, the number of hearts in the deck. And again, instead of 1 to 3, we now have a ratio of 3 to 1. Comparing odds in favor to odds against, there's a little note. The formula for the favorable outcomes is the reciprocal, which means the numerator and denominator get switched. Again, favorable to unfavorable. If we flip that around, or in other words, take the reciprocal of that, we get our unfavorable to favorable. So the odds in favor is the reciprocal of the odds against a certain event occurring.